All right, welcome everybody. My name is Peter Boros, and I'm here with René Canao. And we are going to talk about ProxySQL at Zuora. So we have an agenda for today. The first agenda item we already done. We checked out the nice title slide. Then we go through the agenda. We are here, right? So you can see that it's already a very successful talk because we covered 2 bullet points on the second slide. Then we will introduce ourselves and Zuora. And then we will talk about how ProxySQL helped us abstracting the topology away from the application. How did we implement fast failovers with ProxySQL and what benefits does it have? We will talk about multiplexing and connection pools quite a lot and what benefits do they have. And at the end, if we have time, we will talk about creating scrubbed datasets using ProxySQL. So for the About Us section. About Zuora, who knows Zuora here? So Zuora is a business-to-business company, and we are evangelizing the subscription economy, meaning that we believe that sooner or later, everything will be transformed to subscriptions, and the current business software is not up to the task to handle that. Like, people don't buy DVDs anymore. They have a Netflix subscription. And we are preparing the enterprises for that. We are a SaaS platform that automates subscription order to revenue operations in real time. Some numbers about Zuora. In Q4 2018, we crossed $10 billion quarterly transaction volume going through the system. So we are not like a famous company like Facebook because we are business to business, but it's not small. We have over 1,200 employees throughout the world. I'm actually based in Europe, so we are a very distributed company. And Zuora was named Best Workplace by Glassdoor, San Francisco Business Times, and Great Place to Work. And René, if you...
Yeah, so quick introduction about myself. I'm the founder of ProxySQL. I started this in 2013. And I have long experience in MySQL, around 14 years. And my main focus, so basically my main passions are performance, availability, and solving problems. This was the reason why ProxySQL has been started.
Okay, and I'm Peter Boros. I'm the principal database architect at Zuora. I also have more than 10 years of MySQL experience. And my interests are low-level details and performance tuning, high availability, and tooling around larger MySQL deployments. So let's start with the introduction. What did ProxySQL give us? Why did we start doing it? We use replication, and you can create nice topologies with replication like this or this, right? And we had a quite complex replication topology because we are an ERP type of application, so our workload is not as simple as do the same things all over and over again. The queries can be complex, so we have like this type of slave, that type of slave, third type of slave, and we are sharded as well. And earlier, the application knew about the whole topology, like it knew about what exists in one of our clusters, right? And with ProxySQL, this is not the case anymore. We are just providing endpoints, and we tell the application, okay, we know how to manage these endpoints. This is all you have to care about. Right? Here is a Jdbc URL, and this way, we have freedom to change the structure, to change the underlying infrastructure without touching the interface, without breaking anything. And one of the biggest benefits is fast failover, the fast failover we have with ProxySQL. And I give it to René, who will talk about the background of this, the fast failovers.
Okay, so before speaking about how to implement fast failover, of course, one important thing to have is that ProxySQL need to be aware of the replication topology behind itself. The replication topology initially was not part of ProxySQL, so initially he was replication agnostic, didn't know anything about replication, but from the very beginning, from version 1, basically, the first replication topology that was added was the standard asynchronous replication, and from then on, other replication topology were added. At the very beginning, other replication topology were added using the use of external script. So basically, ProxySQL has a features called the scheduler. It is nothing more than a cron-like features that is able to call external script at regular interval, and those script can do a variety of things like connecting and to the various backend and trying to understand their health check and reconfigure ProxySQL based on those information. With the time passing, native support for various replication topology were added. In 1.3, there was started the initial support for group replication that became native in 1.4. And then in ProxySQL 2, we also have native support for Galera replication, Amazon Aurora, and RDS. So, of course, before being able to speak about failover, we need to have a first introduction about what sort of monitoring ProxySQL performs on the various backend to be able to understand what is the replication topology. Of course, ProxySQL does a lot of health check on the backend, but here we will only describe the health check that are relevant for asynchronous replication. So we are going to ignore any sort of health check that are performed for other type of replication topology like Aurora or group replication and so on. Another thing to keep in mind is that there are several levels of health check, and so there are layers. If a lower layer health check fails, of course, there is no need to perform a higher level check. Very basic example, if ProxySQL is not able to ping the servers, there is no reason to try to check replication log and so on. So specific for traditional async replication, we have the connect check. So basically, ProxySQL connect to this backend and verify that it is healthy. It's also collect a statistic about this, so how long it takes to establish a connection, and all this information are exported ping using the MySQL ping protocol. So it's not an ICMP ping. And if it's able to connect, if it is able to ping the backend, this performs other check like replication log using either second behind master or PT heartbeat. And also it is able to verify if the server is read-only or not. This is relevant if we have a standard asynchronous replication topology. So while performing the various check on the backend, it also determined what is the status of the servers, and the status of the servers is available on the table called runtime MySQL servers. And the various status we have is online. That's quite pretty self-descriptive. Means the server is fully operational and healthy. Then we have shunned. That means that for whatever reason, the server has been temporarily disabled. The reason why the server is temporarily disabled can be a variety of reasons. For example, if the server starts returning too many errors, too many connection errors, or if the server is lagging for a certain period of time, and other conditions. So ProxySQL is able to detect that the server is misbehaving, and in this case, it stops using the server for a small period of time. How long this is configurable, of course. And there are other two important status that are offline soft and offline hard. We first describe offline soft. Basically, when a server is configured in offline soft mode, what it happens is that ProxySQL will allow to execute queries that are in flight, queries and transactions that are in flight, but any new sort of requests are not being sent to the database server. And this also allows to start draining connection to the servers. This is relevant to when we are going to do a graceful failover. And then we have the other offline status, that is the offline hard. When the server is configured in offline hard, all the connections to the backend are immediately terminated. This means also that if there are queries in flights, those queries are terminated. If there are transactions, those are interrupted, and the application, of course, is getting errors. Internally, putting a server in offline hard is equivalent of deleting the server from ProxySQL. So it doesn't even perform anymore any health check at all. Like it doesn't even try to ping the server. So how failover happened? Well, I assume here everybody is pretty aware of how replication works and how the failover happened. So I'm going to be very fast here. We have a primary and a series of replicas. MySQL does not support the failover natively in standard asynchronous replication, so we should rely on external tool like Orchestrator or MHA. And the way those tools act is very simple. They are roughly, of course, the details are different, but roughly they all operate in the same way. So basically, the primary master is configured, is switched from read-write to be read-only mode, and then one of the server that is originally a replica is promoted to be one of the writer, and eventually the original writer become a new replica of the new writer, and then the new writer is configured in read-write mode, so it starts getting writes. So how does it happen? How does this integrate with ProxySQL? Well, in ProxySQL, we also have the concept of replication host group. So basically, a host group is a set of servers that has the same logic and functionality. So in a standard MySQL replication, we can have the writer that is in the host group, in one of the host group, while the readers that are in a different host group. And with a replication host group, we basically define a relationship between two host groups, when one is the writer while the others are all the readers. ProxySQL will constantly check at regular interval the value of read-only, and based on this, it will move the servers to the right host group, either to the host group of the writers or the host group of the readers. So because of this, if you have a tool like Orchestrator or MHA that configure the servers around, ProxySQL is just checking the status of read-only and is able to detect which one is the new writer. So in short, what happened is, as soon as Orchestrator set the first server as read-only, what ProxySQL does says, okay, this server does not belong anymore in the writer host group, so the writer host group will become empty. At this point, new requests are not being sent anywhere because there is no server to send the request, and ProxySQL is able to hold those requests for a period of time that is configurable. That is MySQL Connect Timeout Server Max, that by default is 10,000 milliseconds or 10 seconds. So if the failover completes within this time interval, basically the application doesn't even realize that there was no writer for a period of time. It will just get some latency. And then when the new server is promoted and configured as read-write, select read-only will return 0, so ProxySQL detects this is the new writer and will start sending traffic to it. Simple as that. So, of course, all this can happen during either a planned or unplanned failover, but if we know that we are going to make a planned failover, we can integrate this even better. There are multiple reasons why you want to perform a planned failover. Like, for example, you want to, in this slide, for example, you want to upgrade the hardware, or you want to upgrade the operating system, try a new version of MySQL, perform some interesting alter table. And in this case, what you want to do is perform those, before performing those operations, you might like to perform a failover. And here is where it comes handy, the fact that you can configure a server in offline soft mode. So basically what you can do is you can integrate ProxySQL with the replication manager tool, like Orchestrator, and those tools can instruct ProxySQL that a failover is going to happen very soon, so they can tell ProxySQL to configure the server in offline soft mode. And well, on the next slide, I'm going to show exactly how this happened and the details of how this happened. So this is the original starting point, the same as we were describing before. We can eventually tell ProxySQL to stop the replication host group, so it will avoid performing some automatic detection of which one is the writer and which one is the reader, if we want the replication manager to instruct ProxySQL which one is the new writer. So once we stop this, then the next step is that the replication manager, like Orchestrator, can tell ProxySQL to configure the writer in offline soft mode. When this happens, basically ProxySQL is not sending any more new traffic to the database server, but it allows the current queries in flights and the current transaction to complete. So basically the application won't get any errors at this stage. And then the replication manager can check in ProxySQL how many connections are in flights, how many queries are in flight, transaction, and so on. And when it detected those number is 0, drop to 0 completely, it means that there is no more traffic that is being sent to this server, so all the connection has been drained. So at this point, orchestrator will complete the failover and configure the new writer and tell ProxySQL to configure the status to be online. And at this point, if less than 10 seconds or whatever value you have configured for ProxySQL to hold the connection, the new traffic will be sent to the new writer, and basically the application didn't got any error during this time windows. Now, it is important to define how long is the time windows before setting the server in offline soft and offline hard, because, yeah, so let me just go ahead. I basically described this already. So it is very important to have this to configure the grace time between setting the server in offline soft and offline hard, because the shorter is this grace period, the higher the probability of the application getting any errors, because it means that ProxySQL can actually terminate some transactions that are in flights. On the other hand, if you configure this grace time to be too high, it means that for an extended period of time, your throughput to database will be dropped drastically, because of course there is no backend available, and so the application has nowhere to send the traffic. Okay, so yes, you can configure all this logic in your orchestrator using the various hooks that are available before and after the failover. Now back to Peter.
Okay. So next I will talk about Zuora's implementation of this. We are using a set of head nodes for a bunch of shards, and each head node is running orchestrator, raft, and console servers, and we are storing the role of the given instance, like if it's a master, if it's a slave type A or slave type B, or whatever type of slave, in console key value. And we also expose the Jdbc URLs that serves as an entry point to the host in console key value. So it's very easy for the applications to subscribe it. So we have we are using console as some kind of transport mechanism as well. For each cluster, for each shard we have at least 2 proxies for redundancy. We can have any number of proxies. In case of Graceful Failover, we put them, so how we do Graceful Failover, we put all of them in soft offline mode, then wait for all of them to drain, then do the failover in all of them. And for the unplanned failover, what we do is that if a proxy is unreachable for reconfiguration by the head nodes, it is just removed from console, so it will no longer serve as an entry point. And the proxy itself, if it cannot reach the raft quorum, it will wipe itself. So it also fences itself from serving connections. So we are using console for service discovery, and the application connects to all proxies right now in failover node with a multi-host connection at the Jdbc level. Our applications are mostly Java. And here is an example of a multi-host Jdbc URL. So for DB1 and DB2 in this case are proxies. So you can just list here any number of proxies, and the failover between proxies or the load balancing between the proxies can be handled by the Jdbc driver. This is a very nice feature of the Jdbc driver. I wish other drivers had it as well. So we have head nodes for a bunch of shards. Like in each environment we have a bunch of shards, and each environment has their own head nodes, so they are totally separated. So you cannot perform a failover in production accidentally instead of staging and things like that. So This is for separation, but head nodes you need only per environment. And we are trying to keep the raft ring relatively small. Typically, we have 3 or 5 head nodes per environment. Okay, we are using the soft offline method with a wrapper for graceful failover. And for non-graceful, we are using an orchestrator hook to call the appropriate parts of our software. It's called Jdbc. It's just Python wrapper around orchestrator, ProxySQL, and console, which updates the metadata in console and takes care of the case when the metadata is not updatable. So what it allowed us to do? Now we have non-impactful failover, which means if we do a failover, nobody notices it, and we can do it practically anytime. It takes much less than 10 seconds total. Typically, it's below 5. And the topology manipulation is outside the critical section. So while we are manipulating the topology itself before orchestrator's graceful master takeover call, we are not touching the currently served traffic. The queuing time in soft offline mode is typically 3 or 4 seconds. And we have tests like, we run failover in a loop and still things should be working. And we are doing these tests regularly. This gives us speed on administrative tasks, like operating system upgrades, MySQL version upgrades, any kind of infrastructure changes, and so on and so forth. I would like to echo René here that choose your timeouts carefully for soft offline. It can hurt you if it's too small, and it can hurt you if it's too high. For our workload, 2 to 3 seconds timeout seems to work really well. And one of the examples for the benefits, we have infrastructure in the cloud as well as on-premise. And for example, when AWS released the R5 instances for the public, we were on R3, benchmarked R5, we found it's faster and cheaper, so we could migrate the whole infrastructure to R5 in a relatively short time. Also, there was a time when when people started to discover that large GP2 volumes have guaranteed IOPS, and you might be better off on larger GP2 volumes than provisioned IO volumes in Amazon. Even Percona blogged about this. We could make this transition very easily because of this. So with the instance type change and the volume change meant like a 20% cost reduction in that environment. And because of this speed in the administrative tasks, we can realize the cost savings on the cloud environments immediately. On the on-premise, it can be nice that you can buy servers later, right? You cannot just return the servers and get the money back. But on the cloud, this is like an immediate cost reduction. And back to René, who will be talking about multiplexing and connection pools.
Okay, so basically multiplexing, this is one of the most interesting features of ProxySQL, probably one of the most commonly used. Multiplexing is the ability of having the same backend connection shared between multiple client connections. So this means that there is no one-to-one mapping between a client connection and a backend connection. In other words, this behaves very similar to a thread pool. So it's like the application sends a request, ProxySQL will identify a backend connection that is free, and it will send the request in that connection. Once the request completes, either the OK packet or the result set is sent back to the client, and then ProxySQL will determine if the connection to the backend is safe to be shared, and if it is safe to be shared, it is automatically detached from the client and moved back to the connection pool of ProxySQL itself. Of course, there are multiple conditions that need to be met before to make the connection safe to be shared. And soon we're going to have a look at what are those conditions to make the connection shareable. Before moving forward, I want to show an example of a users that recently moved to ProxySQL. They had around 20,000 connection to MySQL. When they switched to ProxySQL, well, they had a period in which some applications were being shut down and migrating from direct connection to MySQL to ProxySQL, and they dropped their number of connections from around 20,000 to just around 100 connection. And MySQL behaved very bad in terms of performance when you have so many connection, because it used one thread per connection. So if you have 20,000 connection in MySQL, it means 20,000 threads. While like this, it drastically reduced the number of threads and performance improves a lot. Okay, so I was saying that there are multiple criteria to have multiplexing enabled, so to have a connection that is able to be shared between multiple clients, and those criteria need to be met. For example, one of the criteria is that there is no running transaction on the connection, and this seems quite obvious, because if there is a transaction running, you cannot have multiple clients sending queries on the same connection, because otherwise they will all operate on the same transaction. ProxySQL is able to track if a transaction is running, so as soon as the transaction commits or roll back, ProxySQL knows that now the criteria for disable multiplexing, the specific criteria that is transaction running, is not true anymore. So from that point of view, the connection can be shared again. So ProxySQL will move the connection back to its own connection pool. There are a lot of other criteria. Here there are listed some of them. Like, for example, if you have executed lock table or flash table with read lock, of course, at this point, that connection cannot be shared anymore, because there is a lock on those there is a lock table on this specific connection. So ProxySQL has to wait until unlock table is executed on the same connection. When this happens, the connection is moved back to the connection pool. There are other criteria. There are other criteria in which the multiplexing is disabled and never enabled again. For example, if you are creating temporary table, because ProxySQL is currently is not able to track all the table name of temporary table. So as soon as the temporary table is created, multiplexing is disabled and not enabled anymore. And again, the criteria is very simple. If you are creating a temporary table, you want that your next queries are being executed on the same connection and not ending up in a connection where the temporary table is not there anymore, or at the same time, you don't want that another client will access your temporary table. There are other criteria in which multiplexing is automatically disabled. Like, for example, if you are setting any of those variables, like foreign key check, unique check, auto increment, or the increment offset, and basically for those type of set statement, ProxySQL will automatically disable multiplexing. In 2.07, SQL safe update, SQL select limit, and max join size is not part anymore, or does not disable multiplexing automatically, but ProxySQL is able to track them. So multiplexing kept being enabled. There are some exceptions. Also, all the queries that have an at in the query itself will automatically disable multiplexing. Basically, ProxySQL assumes that you are either setting or reading a user variable or a system or session variable, so it will automatically disable multiplexing. If your exception apply, for example, if you're executing select version, ProxySQL won't disable multiplexing. There are a lot of ORM that are executing queries that have the at as part of the query. For example, if they are reading all the session variables, Jdbc is an example of this. For example, it executes a select statement trying to get several session variables, and because ProxySQL does not know exactly what the Jdbc driver is doing, as soon as it sees the at, it will disable multiplexing, and of course this is not a good thing, and you have a way to prevent this, and it's basically you can create a rules that basically instruct ProxySQL that every time a specific query is executed, like if it's coming from Jdbc driver, there is no need to disable multiplexing, and this is the way of doing it. So basically, you create a query rules in which you specify the query type and multiplex, you set it to 2. It means do not disable multiplexing for this type of query. Okay, so how to identify which are the queries that are disable multiplexing? Normally, stat MySQL query digest is the right place of looking into. So, for example, you can look for a set statement. You can look for any query that has an at, and from there you can identify which are the queries that disable multiplexing, and then you can decide if you want to create rules to not disable multiplexing for those specific queries. Also, in 2.06, that was released, this is the last release version, ProxySQL tried to parse every set statement, and if for whatever reason it's not able to parse one, it automatically log an error, and the error log says that it's not able to parse it, and it will automatically disable multiplexing and also query routing. So you can identify those queries from the error log. Okay, another thing that is important, I was mentioning that ProxySQL has a connection pool for every database server, but does not behave the same way of other connection pool, because normally a connection pool, it creates a set of connection as soon as it starts. ProxySQL does not behave in this way, but at the very beginning, it does not allocate any connection. So connections are created on demand. There are multiple reasons for this. The most important reason is that by default, ProxySQL does not know the password to connect to the database server, so it cannot pre-allocate connection, cannot connect. It derives the password from a client connection, so basically it uses the SHA-1 of the password, and when a client connects, is able to get enough information to be able to connect to a database server. And another thing, once the connection is used, the connection is moved back to the connection pool unless the connection pool is already full, or if the number of either connection in the connection pool is already reached a certain threshold. And actually, this is explained very soon. So this is how you configure the maximum number of connections that you have. You can have for the specific database server. So here in this example, we have 4 servers. Actually, there are 3 servers, because this one is the same server that is present in 2 different host groups. So this is the writer, this is the reader host group. This slave is configured with a very high weight, while this one, that is the master or the writer, is configured with a very small weight. So the majority of the traffic goes to this server, .1 to 2. And if for whatever reason this server doesn't become available anymore, this one will be used instead. And ProxySQL, of course, collects statistics about the use of the connection, and you can see those statistics using the table stat MySQL connection pool. There are a variety of information. Here they are listed only few of them. Specifically, you can see the status of the server, how many connections are currently used, how many connections are free, the number of successful connections that has established, number of connection errors, number of queries, and the latency in nanosecond. Yes, microsecond, yes. Next. So before I was saying that ProxySQL does not pre-allocate connection, but at the same time, it doesn't keep all the connection forever. So the connection free, they are not kept, not all the connection free are kept. When a connection is moved back to the connection pool, ProxySQL also determined how many connections are currently free. And by default, it only keeps 10% of max connection. So for example, if you have configured the database server to have a maximum of 2,000 connections, this means that ProxySQL will hold up to 200 connections, that is 10% of 2,000. And the idle connections are also kept alive, having a periodic ping. So at regular interval, ProxySQL is sending a MySQL ping on those connections just to keep them alive and prevent MySQL to close them. Now passing back to Peter.
Thanks. So we are using multiplexing as well, and what I would like to share is a case study. Like, one of our shards became overloaded. At around 6:30 p.m., we received an alert that the database server has 2 high threads running, so the workload is 2 parallel. and it was overloading the server with lots of short queries. We already had multiplexing enabled, but with enough backend connections to map all the front-end connections to the backend connections, because we wanted to put proxy in between first and enabling multiplexing gradually. And we have ways to throttle the traffic at the application level, but now with ProxySQL, we also have a way to throttle the traffic at the database level, which allows for very fine-grained control. Like a way to build resilient applications is to have the floodgates in all the layers, right? And so here we received an error. This is query per second. The scale is not there on purpose. But let's say that this is around 1,000, this is around 2,000, this is around 3,000. So there was some batch workload that we were executing, and some other workload came along. The parallelism was too high. Throughput decreased a lot, like it practically halved. We were paged, investigated, identified the workloads, and so on and so forth. And then we decided to enable multiplexing, or not enable multiplexing, but limit the number of backend connections we allow at the ProxySQL level to 100. And this is what happened with the throughput, right? So it turns out our previous peak was not really a peak, because this was already too parallel, just it wasn't parallel enough to alert us, right? And we immediately saw a much better throughput just by limiting the connections on the MySQL side. As René said, we knew all about the theory, right? That every connection is a pre-thread create, every connection has some overhead. But I guess everybody with sharding has these problems with connections, that the application servers can connect to any shard, right? Then how should you size the connection pool? If you add an application server or you add the new shard, you are increasing the number of connections on each side. So this is a very real scalability limit of any sharded system, and ProxySQL helped us solve that, and probably it could help everyone solve that. So reducing the parallelism allowed the database server to use the same amount of CPU, but instead of using it for context switching, it used it for meaningful work. Hence, we saw the increase in QPS. But okay, QPS was increased, but what about individual query types, you might say? Might be that somebody just started doing select one, right, on the side, and it's very easy to increase the QPS and produce impressive numbers like that. So thanks to ProxySQL, we also we are sending the metadata from stats MySQL query digest to our monitoring system. So we actually have things like QPS per SQL type. So if I would hover my mouse around above these lines, I would see which SQL it is. So we saw an increase across all the query types. But you might say, okay, throughput was increased, that's fine. But it's easy to increase throughput at the expense of latency, right? So how did the latency look after this? And this is the latency per query type before. Again, thanks to ProxySQL's instrumentation. Just by hooking up the instrumentation given by ProxySQL to our monitoring system, we have a lot more insights. And those insights are, because we are using the same monitoring system as the application, it can be easily correlated by developers. So because the parallelism decreased, the response time of the individual queries decreased as well. So we managed to increase the throughput significantly and have better response time. Okay. One thing to be aware of, we have a new error in this case, or you can have a new error in this case, that one client which is connecting to the proxy, if the proxy is queuing, that queue has to have a timeout, right? And that timeout can be hit. And when you hit that timeout, that's an exception. But if I go back to the graphs, like in this case, we did get Jdbc level exceptions that the Jdbc connection timed out itself. And how do you handle Jdbc connection timeouts? It's very difficult, you don't know, right? The server might perform the commit, might not. If it's on the commit, the server might have started the transaction or might not. You know, if the timeout is just on the connection, you don't really know what is happening, right? But in this case, you know exactly what is happening. You know that the connection never reached the database server. You know for sure that nothing happened so far. So it's much easier to implement a retry mechanism for this type of exception than for a generic driver level timeout. One more thing that I want to talk about is that here we already got exceptions. Even if you don't do anything to that exception, just make it user visible, right? Here you have exceptions with 1K QPS throughput, right? If you enable multiplexing between this region, you won't have any exceptions because the system is just able to handle it, right? If the arrival rate is higher than your throughput in the case of multiplexing, then you will have the queue timeouts, but much less than the driver level timeouts you would have in the overloaded case. So even if you don't do anything with it, it's worth it, but this is a new error, right?
This is a symptom effectively of not having a large enough pool underneath, because if you are overloaded previously because you are sending too many queries in parallel, you've reduced the link too far.
Yes.
Or the server simply can't take the load.
Yeah, or
it doesn't actually matter what you do because one way or the other it doesn't actually matter.
Exactly.
Or you have too many transactions running, like transactions that are not being committed.
Okay.
That's going to happen as well.
Okay, so transactional stuff can trigger this more likely to trigger this.
Correct.
Because you have to have separate connections for all that.
Yeah. So ProxySQL is the new thing to blame, right? Because earlier it was always the database. People see a MySQL hostname and port in the exception. Oh, it's the database. Now it's always ProxySQL because people see ProxySQL hostname and port in the database. So it can take the blame away from the database. Now it's not always the database. Now the issue is always ProxySQL. And giving it back to René, I'm not sure if we have time for that.
Maybe a few minutes.
Maybe we will speed this up like crazy and yes.
Yeah, so basically, this is a very short introduction. I will make it a very short introduction to then pass it to Peter because they're basically using ProxySQL also to scramble data. And you can do this with ProxySQL because it has these features of query rewrite. Thanks. So I would be very short. ProxySQL, you can configure it using query rules, and you can map queries. So for example, you can instruct ProxySQL that when it says a specific type of query, this query needs to be rewritten in a different ways. And the way of doing this is just using regular expressions. So you specify what is the match pattern and how to rewrite using the replace pattern. So what allow, I will be very fast here actually. So you can do something like this if you want to force an index, but this is not the example Peter is going to show, but it will be more like this. So like you will be able to rewrite queries, so to not be able to see the content of the query itself.
Okay, so actually René and Fred has an excellent talk about data masking. I put a FOSDEM link here, which has an even more excellent follow-up blog post about how to obfuscate data from MySQL dump. And we used this to build a new scrubbing pipeline, which doesn't take any permanent resources. So how we do it is we just clone an instance or create it from backup, configure an ephemeral ProxySQL for scrubbing with all the scrubbing rules, parallel dump it through the ProxySQL, and upload it to somewhere, and the users, who are experimenting on the database can just, okay, give me this scrub data set or that scrub data set, and we are just creating these periodically. And nothing in this infrastructure is permanent. It can be all ephemeral.
Could you not query through the ProxySQL with read-write rules to do it that way? Or is it?
Yeah, it's that, but it's.
You're pulling the data out to have a static copy, but could you not just query the original data, have it masked that way as well?
Not if I want consistency. For the original data, I could query it on a single connection, but then that would be one transaction, one long-running transaction, and it's much slower. Okay. It's much faster to make a clone and dump it on 20, 40 threads with a stopped slave, right? So that's the reason. Yeah, exactly. So what the developers typically want is a realistic database, realistic scrub database from a single point in time. Right? Yeah. Yeah, that's it. We have. Do we have questions or? No, they say we don't have questions. So thanks everyone. We will be outside if there are any questions.
Thanks.